Okay, so this is the second video for 2.2, and really this is if you can do all these pages first completely on your own, that would be very cool, and then you could come back here and watch the video to see how you did, or if any point along the way if you get stuck. So I would recommend, if you haven't done these yet at all, turn off the video, try it on your own, and then come back. So I will solve all these questions, but I'm kind of hoping that you have at least struggled with or tried or addressed the questions on your own first before you come to me. Otherwise, it's just more of you watching me solve problems. I already know how to solve these problems, and really you learn the most if you try to do as much as you can on your own. And then if you get it all on your own, that's fantastic. If you get stuck along the way, you can sort of see, oh, that's how you do it. So first of all, it says find the x-intercepts of y is equal to x squared minus 25. So the x-intercepts, what that means is find out where it crosses the x-axis. So we're going to have a y value of 0 and an x of we're going to find out. So what we do is we say, okay, let's say that y is 0 here of x squared minus 25. So I add 25 to both sides. I get 25 is equal to x squared. And now, here I'll just write it this way, x squared equals 25. And now when I do the square root of both sides, you'll notice what happens here. I get both positive and negative 5. Why is that? If you just go back to this line, you'll see if I plug in a negative 5 here, it's true, negative 5 squared is 25. If I plug in a positive 5, it's also true. So that's the first bit I'll do here. So now let's go back to do the second one. Same idea, I'll say 0 is equal to x squared plus 3. I'll subtract 3 from both sides. And just because it feels nicer, I'll switch sides here. Now when I do the square root of both sides, and I try to do on my calculator, what's the square root of negative 3? My calculator would say error, right? And really there is no, you can't find the square root of negative value. So I could say here, no solution. So I could just kind of cross that out. Now moving over to question number 3. Where is it? There it is. Let's do the same thing now. Let's find the x-intercepts. So that's when y is equal to 0. So 0 is equal to 32 minus 2x squared. We're going to subtract 32 from both sides. And then we'll divide both sides by negative 2. Maybe I'll switch it around here. X squared is equal to 16. So x is going to be equal to plus or minus 4. Okay, looking at number 4 now, we're going to say 0 is equal to 5x squared minus 50. So 50 is equal to 5x squared. Divide both sides by 5. 10 is equal to x squared. So now x is going to be equal to plus or minus the square root of 10, which is approximately plus or minus, I think, about 3.1 off the top of my head. Okay, so that's the first part. And then it says here, find the x-intercepts, sketch the graphs of number 1 and number 2, and then on the same graph, sketch the square root of each one. So, and another way to write those instructions is, let's pretend that this is, let's just change the notation a little bit. We'll call this one f of x, and we'll graph that, and then we'll graph, perhaps in green, we'll graph y is equal to the square root of f of x. Okay, so for the original function then, the x-intercepts help us because they tell us where they'll cross. Another nice piece to know is where it'll cross the y-axis. Okay, so looking at this function, we know a little bit about parabolas. This is going to open upwards. If I plug a 0 in for x, I'll get a 0, and then I'll get a minus 25. So this is my y-intercept at 0, comma, negative 25. So here, negative 25. So here's my original graph. It's going to look something like that. Okay, so and this is just sketch, it's not graph. Okay, so now for my square root of that, the first thing is this is outside the domain of the square root, so we're not going to have anything there, and our graph afterwards is going to go like that. And if I zoom in a little bit, you can see I purposefully went above the line and then below the line, assuming that this is about where 1 is. Okay, again, kind of like that. So there's what my graph looks like. Okay, so my second one, y is equal to x squared plus 1. Now this is an interesting one. I got no solution. So what that means is that there is no x-intercept. There's no place that the graph is going to cross the x-axis. Looking at the function, it kind of makes sense. It's going to open upwards because this is a positive value, and this looks like y is equal to x squared looks like this, but then it's been raised up 3. So here's my 3, and this is my original function. Alright, like that. So now if I switch to green, and I do my square root function, it's going to be, well, the entire domain. There's nothing where it's 0, so I don't have to worry about that. And where this is 3, now I keep all the x values the same, and I do the square root of the y values. So the square root of 3 is approximately 1.7, so I'll go about here. And now my new function kind of goes like that. Okay, where this is right there is the square root of 3, or approximately 1.7. Alright, now the instructions don't actually say to sketch the other ones, but you know, let's do that anyway. So let's just do a really quick sketch of what these would look like. So okay, back to blue here. So we've got this 32 minus 2x squared. So it's going to open downwards. It's going to cross at 4, and it's going to cross at minus 4. And if I plug in a 0 for x, I would get 32. So in other words, the original function goes like this. This is certainly not to scale because this is 32 up here. My square root of that function here, it's going to be, well, I'll get nothing here and nothing here. This would be the same point. It's going to go over top first and then underneath, and then same thing over there. Okay, so again, if I zoom in, it's got that sort of feature. And what would this value be? It'd be whatever the square root of 32 is. So, oh, I lost something there. It would be whatever the square root of 32 is. Try that again. Like that. The square root of 32, not sure, off the top of my head, somewhere 5 point something. Okay. Alright, let's go take a look at the 5x squared minus 50. And it does have two x-intercepts at negative 3 and positive 3.1. So if I go and sketch a really quick graph here, I got a 3.1 here, and I've got a negative 3.1 here. Looking at this, it should be opening upwards, and if I plug in a 0 for x, I'll get a minus 50. So my original graph kind of looks like this. Pretty ugly looking. And then my square root, again, it'll have nothing where it's 0, and it'll go like this, and it'll go like that. So you see these patterns emerging when we've done the same type of graph a few times. Explain why it's important to determine the x-intercepts. Okay, so just to be clear then, we have the original function of y is equal to f of x, and then we have a second function of y is equal to the square root of f of x, right? If we can find the x-intercepts, it tells us two things. First of all, number one, the x-intercepts are invariant points. Invariant points mean that they're common. It's where these two cross, okay? Common to both of these graphs. And the second one is, it helps us to determine the domain of the square root function. Helps to determine the domain of the square root of the function. Let's see what I mean by that. So over here, the x-intercepts were plus or minus 4, so our domain was in between, right? The domain here would be negative 4 is less than or equal to x, which is less than or equal to 4. So again, these two values were the x-intercepts. This one's a little bit different, right? It's going to be everything to the left of negative 3.1 and everything to the right of negative 3.1. So it would be x is less than or equal to negative 3.1, or x is greater than or equal to positive 3.1. That would be the domain. Again, how do we find those points? Those are the x-intercepts. Okay, let's go on to the next page. It says, sketch the graph of the following functions. We have y is equal to the square root, and the negative square root of 2x. So I think the method that we learned in lesson 2.1, where we start with a parent function, we start with y is equal to the square root of x, and you recall how that looks. It looks kind of like this, and then we make a couple changes. Well, we're going to make two changes here. First thing we're going to do is we're going to say, all right, I've got a minus 2 here, and the second thing that we have is this negative sign over there. So what does that do? So the 2 here, the 2 means that I'm going to be multiplying, it's the b value, I'm going to be multiplying our x values by a half. Okay, so that is that change. Okay, now the negative value means that I'm going to be multiplying my y values by negative 1, otherwise known as a reflection. When you multiply the y values by negative 1, it reflects over the x-axis. So let's start off and draw what we know as, we would say 0, 1, 1, and then 4, 2. So here's my original function, which I'm going to erase afterwards. That is my y is equal to the square root of x. Now let's make these two changes. So first of all, we'll go and we'll say, okay, let's multiply the x values by half. 0, 0 stays the same. This turns into a half over there, and this 4 becomes a 2. So now I'm looking like this, okay? You need to erase. I'll erase these kind of things. We'll get it out of the way. And now I need to multiply my y values by negative 1, which looks like a reflection over the x-axis. So this point still stays the same, but now this is down here. This 2 becomes a negative 2, and I get this kind of a shape. And I will erase my old one here. I will try to erase my old one there. Okay, and so there's my final y is equal to negative the square root of 2x. A good way when you're doing these questions, if you don't have a key in front of you, is to go over to desmos.com and see if you can, let's see if I can get there right away. Let's see if you can type it out, and then you'll find out. So I'll go through this process here, desmos, and I will launch the calculator. And so the first one, I need to go back. Y is equal to, what was it, negative 2 multiplied this square root of x. And there we get something, right? Looks very much like what we just wrote. So I think we're doing well. Okay, so the second one here, we got y is equal to square root of x plus 3. And again, using that same idea of starting with y is equal to square root of x. And then really all we're doing is, this piece here is we're going up 3, right? Up 3. So in other words, add 3 to all my y values. So instead of starting at 0, 0, I'm going to start at 0, 3, and then I'm going to go up 1. This isn't really a great 4, 2. This is not really a great graph for this. It goes all the way up there. Okay. Oh, we should type out what the domain and the range are for each of these ones. So here, the domain. Okay, so the domain for this one, well, what are all the possible x values? So x is going to be greater than or equal to 0. And y values here y is going to be less than or equal to 0. On our second one, again, x is going to be greater than equal to 0. And now our y values are going to be y is greater than equal to positive 3. Okay, so on our parent function, we always start like this. On our parent function, it's x is greater than equal to 0 and y is greater than equal to 0. So if you pay attention to any of these shifts that take place, so here we went up 3. In other words, we added 3 to all the y values, so you'll notice that that happens for our range. We just said, oh, that is a plus 3. That's exactly what happened. When we had this reflection, when we multiplied our y values by -1, you'll notice what happened. Instead of having y is greater than or equal to 0, we had a reflection, so y became negative, so y was less than or equal to 0. So this change from y is greater than or equal to 0 to y is less than or equal to 0 came as a result of this transformation over here, of that multiplying the y values by -1. The multiplying the x values by half didn't change anything, right? It's still, because 0 is still, after you multiply by half, it's still 0. And if everything could just be greater than 0, it's just all the values are less, but they still continue on forever. Okay, so let's try value number c here. So notice that we got the question, and the question is kind of friendly in a way because they already factored out the b value, right? So in this question I could say, all right, b is going to be equal to 2 and h is going to be equal to 2. So what does that b value do? B means that all my x values are going to be multiplied by 1/2. And okay, I'll do the highlight thing here. That's this right there, x values multiplied by 1/2. And then my second thing is that this h being 2, that my x values are going to have 2 subtracted from it, -2. Okay, or in other words, we're going to go left. Oh, sorry, +2. I mix those up sometimes, and right 2. And that is a result of this -2 here, that h value being 2. And so I'm going to be doing that. And a reminder, we want to do the multiplying, the stretches, compressions, reflections, those are all results of multiplying. I want to do that first, and then I'm going to do the adding to afterwards. Okay, so just like before, let's start off and draw our parent function, 4, 2. So here is the parent function. Now we're going to make 2 changes. The first change we're going to make is multiplying the x values by 1/2, and we did that in our previous question. The 0, 0 stays the same, and this 4 turns to 2, so I get this, erasing the old one. Okay, now I need to move my x values, add 2 to the x values, or another way of saying it is move 2 to the right. So I'll start here. This is 1/2, 1, so I'll move over another 1/2, so it'll be 2.5, 1, and this will be moving over 2, it'll be right there. So here is my new. Okay, so just as a reminder, then this is 1/2, or 0, or sorry, 2.5, 1 is that point here, and then this one is pretty clear to see that's 4, 2. And I'll erase my old one again. Alright, so there's how you do that. How about the domain and the range? Okay, so the domain on this one is going to be x is greater than equal to 2. Well, let's analyze this. Again, for my original function, my parent function, what we started with, it's usually the domain is x is greater than or equal to 0. So why did this change to this? Well, the multiplying again didn't do anything, but the +2 changed it to x is greater than or equal to 2 when I moved it over to the right. What happened to the range? Well, there were no changes in my y values, and if I see it again, the y values can go from greater than 0, greater than or equal to 0, so that stays the same. I'm going to go down to letter E here. I'm going to go a little bit out of order because it's the same question, but now it says using another method. So really the method, I'm going to call this method, from lesson 2.2, which is really what we're going to do is we're going to say, well, if f of x is equal to 2x minus 4, we're going to graph that, and then we're going to say, oh, well, now let's use our rules. What happens when we do the square root of that? So 2x minus 4, let's graph that first. So it's going to have a y-intercept of minus 4, which is a little bit problematic because it's over here. So it starts down there. And then it has a slope of 2. So it would hit this point, hit this point, it would hit that point, and then it would hit some point up there. Okay, so kind of hard for me to freehand that straight line. Okay, so there is my y is equal to 2x minus 4. Now I need to do the square root of that. And you'll remember the first thing I do is I say, okay, wherever it's negative, forget about it. And then I have two invariant points here and here. And it goes over top there. Okay, and then the rule is wherever in the rest of the line, keep the x values the same, but do the square root of the y values. Well, this up here would have been 4, 4, so it's going to be 4, 2. So it's going to be going. I didn't draw that very well. Let's see if I can fix that a little bit. There, I'll try it again. So it's going to go above and then like that. Okay, where I have to be careful that this blue line, all right, it goes. There we go. Didn't do that well. One more time. Let's do this better. Okay. If I draw the blue line first, and I draw the blue line like that, then my green line has to meet it here, and it goes over it, and then goes under it, like that. Okay? Now, if I erase my other junk, let's see if I can here. I'll erase this other stuff. Let's compare. How do we do compared to our previous version? And yeah, it looks exactly the same, doesn't it? It went through those same points. Okay, and the domain and the range, of course, will be the same. Let's take a look at d now. Y is equal to the square root of x squared minus 3. So I think this method that we just used, where we look at f of x is equal to x squared minus 3 first, and then we say, okay, then we're going to graph the square root of that. So x squared minus 3 starts at minus 3 here, and you'll recall that it's a good idea to figure out what the intercepts are. So if I say 0 is equal to x squared minus 3, I'll get 3 is equal to x squared. So x is going to be equal to plus or minus the square root of 3, which is about plus or minus 1.7. So at 1.7 here and negative 1.7 there. So this is my original function. Oh, I kind of missed over there. And now I say, okay, now I want to do the square root of that. So when I do the square root, I get rid of I don't worry about any of this. Here's an invariant point, here is an invariant point, and then wherever y is equal to 1, it goes over that and then under. Okay, so again, it is just a sketch, so I don't have to be too neat here, and then I'll erase the other stuff. So that's how that function will look. The domain in this one, so the x is less than or equal to negative 2, or x is, oh, not negative 2, it's square root of 3, isn't it? So x is less than or equal to the square root of 3, or x is greater than or equal to the square root of 3. And the range will be y is greater than or equal to 0. Okay, so now it says f y is equal to the square root of x plus 1 using either method. I think it's probably easiest to say, oh, let's start with our parent function like that. And what's going on here? This is an h value of negative 1. In other words, I want to go left 1. So my new function will be left 1 from that. And if I take each of the points and go left 1, then I get this kind of look, and I'll erase my old one. And there you go. I think that's the easier method for that. Okay, let's take